Hey everybody, Dr. Wallace here. I'm going to do another video for an example of a topic that you are ready to learn in ALEKS. So the first one here is to find a polynomial of degree 4 that has zeros 0, 3, negative 4, and 9. And the question actually says then to leave it in factored form, which of course we would do if they didn't say anything at all. That's easier. Anyway, this comes from the fact that if a function equals 0 at some number c, then x minus c, that expression is a factor of the function. Okay, this is called the Factor Theorem. So if f of 0 equals 0, then that means x minus 0 is a factor. If 3 is a factor, then x minus 3 is a factor, and so on. X minus negative 4, x minus 9. Now, if we were going to go ahead and FOIL this out, we would get something of degree 4. Okay? So I don't have to add anything else. It's already a polynomial of degree 4. Of course, we're pretty much done here. If you want, you can simplify it a little bit, but don't FOIL out, because that is not necessary. X minus a minus 4 is x plus 4, x minus 9. Okay, so here x minus 0 is a factor, so x minus 3 is a factor, so x minus 3, and so on and so forth. This is the answer. Okay, these are easy. Now, if it said it wanted a degree higher than this, we might add multiplicity. If it had said that the 0, 3 had multiplicity 2, then we'd have to put a 2, exponent of 2 above the x minus 3, that kind of thing. Okay, but this is all we have to do to this one. Now, there's another topic that you're ready to learn, and that has to do with polynomial long division. So I'm going to show you how I work those. So this one here is polynomial 3x squared plus 17x plus 10, and we need to divide that by the expression 3x plus 2. Okay, so we're going to use long division. Now, when you use the long division symbol, okay, you got to make sure that all of the terms are lined up in order as if they were places. Like when you do long division of numbers, you have to have a 0 for a placeholder in the hundreds place. Even if the number was 3010, right, you have to put a 3 and then a 0 for the hundreds place, and so on. So if this didn't have a 17x here, for example, I would need to put a 0x there to make sure I have all the placeholders where they need to be. But it turns out that that's not necessary for this one. Anyway, how do we figure out the quotient? Well, we take the first term here and we see what do we multiply that by in order to get the first term of the dividend, right? So we need to figure out what do I multiply 3x by in order to get 3x squared, and I actually put the wrong thing at first because I wasn't thinking, but x times 3x gets me 3x squared. Okay, but then I have to carry out the distributive property and multiply the x by the 2 as well. So now I'm going to take that whole thing and I'm going to subtract from what's above it. And the reason why we did this is because we want to eliminate the first term. So 3x squared minus 3x squared goes away. 17x minus 2x is 15x. And the 10 is going to drop down here because that's going to be something we're going to subtract off also. All right. Now we need to figure out what times 3x makes 15, and that's going to be positive 5. So 5 times 3x is 15x, plus 2 times 5 is 10. This example actually factors exactly. The remainder then is 0. Okay, so that's what comes out here, remainder. Since the remainder is 0, that means that 3x plus 2 actually is a perfect divisor of 3x squared plus 17x plus 10, with the quotient up there at the top of our diagram here, right? So in this case, since the remainder is 0, we could factor 3x squared plus 17x plus 10 into two linear terms this way, and if I FOILed out over here, I would get back to there. Okay, so that's not always going to be the case. Sometimes there will be a remainder here. The remainder will be the last solution you get when you subtract off, and then it needs to have degree less than the divisor, and that's how you know you've done. Okay, thanks a lot and have a great week.